All right, we are going to talk about Le Chatelier's principle. So, Le Chatelier's principle is all about reducing stress on the system. So, here is the system. Okay, we have an exothermic reaction. We know it's exothermic because the energy is on the right side, so that means it's releasing energy, which, like I said, means it's exothermic. Okay, so these are all the conditions that we have to decide which way it shifts and what happens to the concentrations of our reactants and our product, and also what happens to the KEQ. Now, first one, we have if we add N2 to the reaction. Okay, N2 is on the left side. Okay, if we add something, the reaction is going to shift away from the thing that we added. So the reaction will shift to the right. Now, if the reaction shifts to the right, that means the other reactant, H2, is going to decrease because it will form more product. So H2 will decrease. And again, since we're shifting to the right, the product, NH3, will increase. Now, KEQ is really easy. It only changes when the temperature changes. So this will remain the same, just like in the previous one. Now, next one, if we add NH3, then we are adding something to the right side of the equation. So it's going to, again, shift away from the thing that is added. So it's going to shift to the left this time. Now, if it shifts to the left, the reactants will both increase. Okay, and again, KEQ will remain the same because the temperature did not change. Now, if we remove something, so number 4, if we remove something, then the reaction will shift towards the thing that gets removed. So if we remove H2, H2 is on the left side, so it will shift towards the H2 to the left. And if it shifts to the left, the other reactant, N2, will increase. And the product, since it's shifting away from that, will decrease. And again, the KEQ stays the same. Number 5, if we remove NH3. So we remove something on the right, so it will shift towards that removal. The products will decrease. And the KEQ, again, stays the same. All right, next we have a decrease in temperature. So first we have to determine that this is, like we said earlier, an exothermic reaction. So if we decrease the temperature, that's like we're taking energy away from the reaction. So if we're removing energy, and energy is on the right side, that means it will shift towards the thing that is being removed, so to the right. If it shifts towards the right, then the reactants will decrease and the products will increase. Okay, now since the temperature changed, the KEQ will actually change this time. So the KEQ, basically the KEQ is going to do, if the temperature changes, the KEQ will do whatever the product does. So since the product increases, the KEQ will also increase. Okay? Now, when we have a pressure difference, we are going to have to count how many moles of gas there are in the reaction. So let me erase this stuff real quick. So if we have a change in pressure, then we have 1 mole of gas here, 3 moles of gas here, so a total of 4 moles of gas on the reactant side. We have 2 moles of gas on the product side, so that means we have more moles of gas on the reactant side than the product side. So if the pressure increases, that means the system wants to decrease that pressure by shifting towards the side with fewer moles of gas. Okay? If the pressure increases, then the system is going to want to shift towards the fewer moles of gas, so it will shift to the right. When it shifts to the right, the reactants decrease, the products increase, and again, the temperature is not changing, so the KEQ stays the same.